like a review. So I'm going to write review for quiz scale drawings scale factor. I guess if we can take advantage and so that you can get used to what the reviews that I do look like. So this is probably it. Very simple. I try to give you questions that you will see, right, or topics that you should be very, very familiar with. So let's get on those. Nope, too big. All right, so I know some of you were not in class because you got pulled out. Some of you were absent. So some of you might just need a little extra when going over this for the next 2 days. We have nothing better to do. So when we were doing this in class, I asked you guys to translate this into simple language. Which pair shows a scale copy that has a scale factor of less than 1? Yuck. So which of these three show that the scale copy is smaller than the original, right? And why do I say smaller? Because if they use a scale factor of less than 1, then the resulting image has to be smaller. Okay? It could be a lot smaller, it could be a little bit smaller. Whatever it is, it's smaller. So if you look at number 1, that's the original, and that's a copy. Because the scale factor is less than 1, this would definitely be one of the choices. It got smaller. Original to the copy, notice it got bigger, so there's no way that they use a scale factor less than 1 here. Okay. It has to be greater than 1. I'm sorry. And this one, if you look at the original and the copy, they're exactly the same. So it was also not a scale factor less than 1. So anytime you use a scale factor less than 1, what's going to happen to your image? It's going to get smaller. So that's what you should have been thinking about. Second one, which of these pairs show a scale copy that has a scale factor of 1? So if the scale factor is 1, your original shape and the copy should be exactly the same. Well, look at this one. The original started here, it went from this one. Are they the same? No, it got bigger. So this is not a choice. The second one, here's the original, here's the copy. They are exactly the same. So this qualifies. And the last one, obviously, went from this, the big one to small, so you can see that the scale factor is not 1, but it's actually the top one. It's less than 1. So when the scale factor is less than 1, it was a reduction, which is what happened over there. So the only one that mattered for this question was that. Which one shows which pair shows a copy, shows a scale copy that has a scale factor greater than 1? So if it's greater than 1, if the scale factor used is greater than 1, then it means that it got bigger. Okay, so let's see. Original copy, like this way. Did it get bigger? Yeah, so this one is one of those. Original is this one, and then it went to the copy. Did it get bigger? Yes, it did. So, did they use a scale factor greater than 1? Yes, they did. Original copy, did it get bigger? Yes. So did they use a scale factor greater than 1? They did. Okay, so in this case, this one, and this one, all three were the correct answer. Number 4. Okay, so you're definitely going to see something like this where you're asked to find scale factor and the missing sideline. So notice right now that this is missing. And this is missing. And I can't find those without knowing what the scale factor. I don't know. So we definitely know from here to here, if you look at the numbers, if you compare the diagonal, the 5, it is now 7.5. So it definitely got bigger. But I don't know by what. 5 times what number gave me 7.5? Well, once you find that, you can use that scale factor to find the missing, the incomplete sides. Excuse me. So, scale factor, SF. If it's going bigger, it's big over small. The only two numbers I can use is 5 and 7.5. If I want to use 4, guess what? I can't because I'm missing its corresponding side. And then if I want to use 3, I can't because the bottom here is also missing. So the only one I can use is 5 and 7.5. So between those two, this big number is 7.5 and the small number is 5. If you simplify, you get 1.5, which, remember I told you in class, I'd much rather you use 3 over 2. It's just easier so that then when we need to find a reciprocal, it's such a much easier process. So 1.5, so to go from here, from 5, it was times 1.5. So let's see if we can apply that to any of the missing segments. Yes, I can use the 3. So how do the 3 is going to change to something but multiplying by 1.5. So what's 3 times 1.5? Well, now we know this one, 4. And now how did the 4, and then the 4 also, right, so we're going to multiply by 3.5. 4 times 3.5 is 14. So now, we go back here and fill this, because now I know what it is. It's 14. Now, the scale factor to go from the small one to the big one is 3 over 2. What if I reverse it? What if I want to go from the big one to the small one? All right, so I know going this way is 3 over 2. But going back would be the reciprocal. And what's the reciprocal of 3 over 2? 2 over 3. Okay. So we did A, we found the reciprocal. Find the missing lengths, we did. 14 and 4.5, we did. And then, let's look at the ratio. AB is 4, BC is 3, EF is 14, and FG is 4 now. They're asking us if that's the same. Well, you can cross multiply, right, do the butterfly, and see if their products are equal to each other. So this would be 3 times 4.5. Sorry, something wrong here. Why did I multiply by 3.5? Sorry, 1.5. No, I'm good. No, that was right. No, it's 4 times 1.5. I did this one wrong. This should have been a 6. Apologies. Okay, so 4 over 3 and 6. 6 over 4.5. We can cross multiply, and if you multiply 3 and 6, you get 18. You multiply these two, 4.5 times 4 is also 18. So are the ratios equal to each other? Yes, they are. So 5 and 6 is just reinforcing the little bit of find the scale factor we did in the previous problem. So let's take a look at this. Read the problem first. Triangle DEF, which is this guy here that I'm highlighting, orange. This is a scaled copy of ABC. So this is the copy. That's the copy. It means that we went this way. So therefore, we went like this. So did it get bigger or did it get smaller? It got smaller. So let's find the scale factor. To get smaller, it's small or big. Let's find two corresponding sides that we can use. And we're going to use, well, the 20 I can't because I don't have a value. I have y. And then I can't use a 9 because the corresponding side here in the bigger triangle is x. So I don't know the value. But I know this. On this side here, that's 16 and that's 12. So we're going to use 16 and 12. 16 over 12, sorry, 12 over 16 because it's big over small. Divide by 4 becomes 3 over 4. So the scale factor is 3/4. Now that makes sense because it got smaller, so it's definitely less than 1. So now, if you look at this, to go from this triangle to this triangle, everything has to be multiplied by 3/4. So 16 times 3/4 is 12. 20, and I'm going to multiply that by 3/4 right now. It's going to be 15. Okay. Now, I need to find x here. But x it's on the other side, so it's going from here to that side. How would I do that? Well, if going small to big is 3/4, the reciprocal would be the factor going the other way. So going from 9 to that way, we're going to multiply 9 times 3/4, which is not 3/4, 4/3. I forgot that we have to use the reciprocal. Apologies. 9 times, not 3/4, but the reciprocal, which is 4/3. And 9 times 4/3 is the same thing as 12. So going the other way, you find that the length of the missing side is 12. What in the world? Okay. So try the next problem, which is exactly, oh well, not exactly, but it is very similar to the one we just did. So we're talking about polygon RSTU, which is this guy over here, is a scale copy of MNQP. So we went this way. So it got bigger. Let's find a scale factor. Scale factor is big over small. Right, let's get bigger. Let's find two corresponding sides, and we're going to use 18 and 30. That's the only pair that I have. All right, so 18 and 30. So between 18 over here and 30 over here, the big number is 30. Small number is 18. If you simplify that, divide 30 by 6, you get 5. Divide 18 by 6, you get 33. The scale factor is 5/3. So, just to prove it, if you took 18 and multiplied that 5/3, does it equal to 30? Yes, it does. Okay, so you can simplify, and 6 times 5 is 30. So, that works out. So, let's use that and find this side here that we don't have, the one that says y. So, to find y, we can take this 15, it's going bigger, and we're going to multiply that by 5/3. Which is going to give us 25. Okay. Now, what if we went the other way? If going this way, the scale factor is 5/3, which means it's getting bigger. What if I return the other side? Well, to return to the other side, it's getting smaller, so the reciprocal would, the scale factor would be the reciprocal 5/3, which is 3/5. So, to find this side here that's missing, this side is missing, which is this side, which corresponds with that. 25 has to be multiplied by 3/5. 25 has to be multiplied, apologies. By 3/5. 25 times 3/5 is going to be simply 50. This side over here becomes 50. Let's try the next two. I think the next two is good practice. Alright, so it just says find the scale factor. So if we're going this direction, it's getting bigger. Right? So the scale factor I'm going to use is going to be big over small. Let's pick two corresponding sides. Let's pick this one, 18 and 24. If I use big over small, it's going to be 24/18, which I'm going to simplify. I'm going to divide 24 by 6 and 18 by 6. 24 by 6 is 4. 18 by 6 is 6. Sorry, it's 3. for the scale factor to go from the small green triangle to the bigger gray triangle is 4 over 3. So if you take 18 times 4 over 3, you get 24. Take 8, if you take 9 times 4 over 3, you're going to get the other side too. But what if so the scale factor going in that direction is 4 over 3. What if it's going this way? What should the scale factor be? Well, the scale factor is going to be the reciprocal. What's the reciprocal of 4 over 3? 3 over 4. Next question, same thing. Right? So if you want to go, well, you could have gone this way too, right? All the numbers are complete. So this one's kind of easy. Scale factor, big over small. And let's pick two corresponding sides, and let's pick the easiest one. This 2 and this 12. Big number is 12, small number is 2, and 12 over 2 is just simply 6. So how did it get bigger? Everything was multiplied by 6. And we can confirm that. 14 times 6 is 84, 9 times 6 is 54, 15 times 6 is 90, and so forth. But what if I wanted to go back now? What if I want to go from big quadrilateral to the small one? What do I multiply 84 to get 14? What do I multiply 12 to get 2? What do I multiply 90 to get 15? Well, what's the reciprocal of 6? It would be 1 over 6. Okay. Hopefully that helps. Draw a scale copy of with a factor of 3 over 2. Okay, I need a little water, so I'll be right back. Oh. All right. So for the next one, draw a scale factor of 3 over 2. So what's the first thing you should have done or should do? Well, that was me. First thing I'm going to do is write some numbers out, some measurements. So 1, 2, 3, 4, 5, 6. That's a 6. That's a 2. That's 1, 2, 3, 4. That's a 1 here, right? A tiny 1. 1, 2, 3. 2 going up. 1 going right. 1 going up. So there. Now 3 over 2, scale factor. So you're going to take each of these numbers. Now let me do it on the side. So you're going to go 6 times 3 over 2. You're going to go 2 times 3 over 2. You're going to go 4 times 3 over 2. You're going to go 3 times 3 times 3 over 2, and then we have one more. 1 times 3 over 2. So 6 times 3 over 2 is 9. This is going to be 3. This is going to be 6. 3 times 3 over 2 is going to be 4.5. And 1 times 3 over 2 is just going to be 1.5. So now you don't have to guess. So if you were to draw this, right? So now you have all their measurements. So the side that measures 6, it's not 6 anymore, it would be 9. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the size that measures 6. Let me change colors. The size that measure 1s, these two that are 1s, it would be 1.5. So you guys are going to go, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one would be 1.5. So 1.5. Going to the right, 1.5. Going down, so the side that measures 2 is not 2 anymore, it's 3. So it's going to be 1, 2, 3. The side that measures 3 is no longer 3, so here has to measure 4.5. So we're going to go 1, 2, 3, 4.5. And then we're going to go up, how many? When it's 1, it's 1.5, so we're going to go all the way up to here. and that's a 4, so it's now a 6. 1, 2, 3, 4, 5, 6, and obviously this would be 3. And that's a shape that has been increased by a factor of 1.5. So to make life easier, put the side lengths, multiply everything by 3 over 2, and you get your measurements. Okay. This one requires a little bit of thought. So here is an original. The original, let me write, original. You don't need a perimeter, but I'm going to write it anyway. So original, perimeter, and the area. Right, so the original has a perimeter of, let's see, 1, 2, 3, 4. You know what? I'm not even going to count. Let me just write the numbers down. So this measures 4. That's 4. That's 2. That's 2. So that makes it a 12. The area, 1, 2, 3, 4, 5, 6, 7, 8. So I know they didn't ask, so just bear with me for a little bit. But imagine I asked you what happens when the scale factor is 2. Well, when the scale factor is 2, I'm just going to build. Everything doubles. This is no longer 2, it's now 4. The 4 is no longer 4, it's 8, right? So that's what would happen when a scale factor of 4. Everything would double. Well, the perimeter, if you take your dog out for a walk, well, if you add this, 4 plus 4 plus 8 plus 8, guess what? It's 24, which means that the shortcut would have been just doing 12 times 2, which is 24. What about the area inside, this space inside? Well, I didn't draw it correctly, so we can't use those boxes, we can't count. But what was the pattern that we saw? Well, the pattern that we saw was that if I take the scale factor squared, multiply it by itself, and then times the original area, I get my answer. So if the scale factor was 2, take it to the second power, multiply by itself. 2 times 2 is 4. 4 times 8, which was the original area, is 32. Yeah? Now, what if I did a scale factor of 3? How did the perimeter go? Well, obviously this would be compared to the original, right? So this is, if the original is 2, let me erase this. All right, so if I did a scale factor of 3, that means that 2 is no longer 2. Times 3 is 6. That 4 is no longer 4 because it's times 3, now it's 12. So notice that it got bigger, right? What is the perimeter? Well, we can take the shortcut now. Just multiply 12 times 3, we get 36. How do we get the area inside? How many little square units are inside a shape that's 3 times bigger? Well, scale factor to the second power, right? So we're going to take scale factor 3, multiply it by itself, and then times the original area. 3 times 3 is 9, times 8 is 72. See where I'm going with this? So now the question here, and I don't know if this helps or not, the question is, hey, what happens when the square, let me give you this ahead of everybody. The area was in 28. What was the scale factor? Well, think about what's happening. You can continue this table. Actually, you could have continued this table. Maybe use a table, see if you have patterns that you could have. Used. So, let's actually continue building. What's the scale factor of 4? Then you would have done 12 times 4. This would have been 48. And then you would have done 4 to the second power, 4 times 4, which is 16. And then times 8. Actually, 8 times 6 is 48. Carry 4. 8 times 1 is 8. Times plus 4 is 20. Actually, there you go. I actually found it. The scale. So I can even erase this. We actually found it. could we have done this algebraically? Well, scale factor to the second power times the original area equals 128. That's what we were looking for. So think of scale factor as your variable. All right. Hopefully you remember this from last year. We could have simplified both sides. We could have divided both sides by 8. If we divide this by 8, divide this by 8, that goes away. I'm left with scale factor to the second power equals 128 divided by 8. Let's see, that carries 1, 16, right? And then what number times itself equals 16, because that's what it says here, right? Scale factor of a number, scale factor to the second power equals 16. And the only number times itself to equal 16 that matches our case would be positive 4. So 4 to the second power 16. So the number we were looking was 4. So I guess one thing you can do is continue the table, right, until you reach the number that they were asking for, which was 128. So we didn't have to go too far. We only had to go to a scale factor of 4. Last one is pretty close to what we just did. And I think, let me add, I don't know what I added. 7, I'm going to add 7 and 10 here. I don't know why I left it blank. Let me use 7 and 10. The original, this is the original. This is a 4, this is a 4, this is a 3, and this is a 3. So if you take your dog for a walk, a full lap around this shape, it would be 14 units. The area inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or, if you remember, the area of the rectangle is base times height, length times width, 3 times 4 is 12. Right? Now, without doing anything else, what happens to the perimeter when there's a scale factor of 2? When the scale factor of 2, it means everything gets double. So this, right, you get a bigger rectangle, and everything gets double. So this is a 6, this is an 8, this is a 6, and this is an 8. So you take your dog out for a walk, what happens to your pyramid? It's double the distance. So you can just simply multiply 4 times 2. What if you triple the distance? Sorry, triple the length of each side? Well, it's the original times 3, which is 42. What if you quadruple? That is 56. What if you increase it by a factor of 7? So, 98. And if you increase each side, so imagine increasing the original one by a factor of 10, that means that this would be 30, right? This would be 30, this would be 40, this would be 40. Increase it by a factor of 10. So 14 times 10, the distance to walk around the shape now is 140. So find the perimeter is pretty easy, right? Just multiply the perimeter by whatever's the original perimeter by whatever scale factor is given to you. Now, what about the area? Now, let's do the double. So if I double that, this was 8, this was 8, this was 6, and this was 6. And if you were to count, right, or if you multiply the length times width, you would get 48. Right? How about a 3? Well, if you had a rectangle that was grown by 3, this would be 12 and this would be 9. Right? What's the area inside? Well, the area inside is 108. Now remember how we get that? We found the pattern the other day, and we noticed that if you take scale factor, multiply it by itself, or take it to the second power, which is what that means, and then multiply that by the original area, you don't have to draw anything. Let's take a look at, let's start at the bottom. Scale factor of 10. Well, 10 to the second power is 10 times 10, which is 100. Multiply that by the original area, which is 12, you get 1200. 7. 7 to the second power is 49. Right? 7 times 7. And then you multiply that by 12. Let's see what we get. 98, 49, 8. You get 588. And then scale factor of 4 would be 4 to the second power, which is 4 times 4 is 16, and then times 12, which gives us 192. So it's a nice little shortcut there. Please familiarize yourselves with what we're doing right now, okay? And you should be